Hey guys, Mr. T here, just doing another video. This one is on isosceles triangles. So an isosceles triangle is a special triangle where two of the sides are equal in length. Okay? The two sides equal in length decides how long the remaining side is. So the angles opposite to the two equal sides, they're known as a base angle. So I've drawn an isosceles triangle here. You can see it's a triangle with a side equal, two sides equal in length. So the base angles are opposite the two equal length sides. So that's opposite there, that's opposite there. So these two are the base angles. And the angle opposite the remaining side, so the leftover, the third side, is known as the apex. So that is the apex. So isosceles triangle has some special properties that you can use in geometric reasoning. The features of an isosceles triangle, those two equal sides and those base angles, give an isosceles triangle some special properties. The first one being the base angles are equal. So you can see in this isosceles triangle, it's not isosceles yet until I indicate those are the same size. The base angles are going to be exactly the same. So A here is going to be the same as that angle there, A. The second special property is that the line going from the apex down to the midpoint of the base bisects the angle at the apex and is perpendicular to the base. So the line we're talking about here, going from the apex down to the midpoint of the base, here, cuts this apex angle in half. That's why you've got a B on either side. And also, if it hits the midpoint of the base, it's going to meet the base at right angles. Also, it's bisecting the base, so this side should be the same length as that side. Now, given the converse of those properties, so I can use those properties in reverse. So if a triangle, I knew that it had two equal length sides, that lets me decide that it must be isosceles. There's no alternative to that. And then two, if a triangle has a line that bisects the apex angle, then the line will bisect the base of the triangle at a right angle. So it's basically using those special properties in reverse. Okay? So just to do an example of doing a problem involving a isosceles triangle, find x degrees in the following figure. So you need to do your two-column proof, which is a statement on one side and the reason on the other. So firstly, I'm going to say that QPR is isosceles. Why? Because PR is equal to QR. So firstly, I'm saying that QPR is isosceles because I know that side PR is the same length as side QR. Because I know that it's isosceles, therefore, angle RQP is going to be equal to the angle RPQ. So that angle there, 52 degrees, is going to be the same as that angle there, also 52 degrees. So I'm saying they're both going to equal 52 degrees, percent degrees. Why? Because triangle QPR is isosceles. So firstly, I've said that it's isosceles, and then I'm using a property of isosceles triangle, which is the base angles are equal. So I've said because QPR is isosceles and base angles are equal in isosceles. Okay, so now that I know that QPR is 52 degrees, I can work out more. Therefore, so the next thing that I can work out is that therefore angle PRQ is going to be equal to 180 degrees minus 52 degrees minus 52 degrees. Why is that? Because angles in a triangle equal 180 degrees. So I'm using a fact about triangles in general, which is that their interior angles add up to 180 degrees. And I'm going to use that fact to work out what angle PRQ is, which is 180, take 52, take 52, it's going to give you 76. So angle PRQ is equal to 76 degrees. So I know that PRQ is 76 degrees. And that will give me the answer to X. Therefore, angle, no, I don't need to call it angle, and X degrees is going to be 180 degrees minus 76 degrees. Why? Because angles in a straight line has an angle of 180 degrees. So X is going to be 180 take 76, which is going to be 104 degrees. Okay, so that's an example of using isosceles triangles properties and also general triangle properties to use some geometric reasoning to work out an unknown. Hopefully that helps you out, and I'll see you in the next video.